For today's video, we are talking about dilation. So our learning target today is I can dilate images centered at the origin on the coordinate plane. Please write down the date you're watching this for your own records. Write down your I know. You may not know what a dilation is, but you know what the origin is. That is the center, 0, 0. You know what a coordinate plane is. And then we have 4 vocabulary words today. First one is dilation. A dilation is to change the size of a figure while keeping the shape the same. Next is enlargement. An enlargement is to increase in size. Next is reduction. Reduction is to decrease in size. And finally is scale factor. Scale factor is how much something is multiplied by. So at this point, please pause the video, get all of this written down, and then restart when you're ready to go. All right, so dilating a figure means that we are going to multiply the coordinates of each vertex by the scale factor. So what we've been doing with transformations when we have been reflecting and translating is we have been creating congruent figures, figures that are exactly the same by sliding them, by flipping them. When we dilate something, we're going to be changing the size, and we are going to be creating similar figures, not congruent figures. And we're going to be doing that by multiplying the coordinates of each vertex. So we're going to graph the image of rectangle KLMN, which you can see here in green, after dilation with the scale factor of 2. So to do that, we're going to start by listing the coordinates of each. So the point K is at -4, 4. L is at 4, 4. M is at 4, -4. And N is at -4, -4. So now, if we want to graph the image after a dilation with a scale factor of 2, all that means is I'm going to multiply every number by 2. So for K is at -4, 4. So for K prime, I'll do -4 times 2, which is -8. And then 4 times 2, which is 8. So my new point will be at -8, 8. And that will be K prime. Now I can do the same thing for my other letters. For L prime, I'm multiplying 4 and 4 each times 2. That will be 8 and 8, giving me L prime. M prime will be at 8, -8. And M prime will be at -8, -8. So my new image of K prime, L prime, M prime, N prime, as we can see, it is a new rectangle. It's the same shape as my old green rectangle, but it is bigger. This is an enlargement by a scale factor of 2. Anytime I multiply something by a number bigger than 1, it enlargement. I end up with a bigger shape. So let's look at what happens when I multiply by something smaller. This time we're going to graph the image of rectangle PQRS after a dilation with a scale factor of 1/4. So before we saw that when I dilate by a scale factor bigger than 1, it's an enlargement. So now we want to look at what happens when it's a scale factor smaller than 1. This case is 1/4. So I like to do very similar to what we did before and list out the coordinates of P, Q, R, and S. P right now is at 0, -4. Q is at 8, -4. R is at 8, -8. And S is at 0, -8. Now I need to find P prime, Q prime, R prime, and S prime. To do that, I'm multiplying all these numbers by 1/4. I know that multiplying by 1/4 is the same as dividing by 4. So I can just do that on my calculator. So all of these I'll be multiplying by 1/4 or dividing by 4. So for 0 divided by 4, well, that's 0. And then -4 divided by 4 is -1. So P prime is at 0, -1. For Q prime, 8 divided by 4 is 2. -4 divided by 4 is -1. So Q prime is at 2, -1. Again, all I'm doing is performing the same operation. Sorry, this should be a 4, not a 2. On all of these, multiplying by 1/4, which is the same as dividing by 4, on every single number for every single coordinate. For R prime, 8 divided by 4 is 2. -8 divided by 4 is -2. So R prime is at 2, -2. S prime is at 0, -2. So I can see that my new rectangle, it's still a rectangle, but my new red rectangle is a very tiny little rectangle. So when my scale factor is less than 1, it is a reduction. It got smaller. So the first thing is going to be able to be taking a shape and either enlarging it by a scale factor or reducing it by a scale factor. But the other thing I want to be able to do is look at a picture and figure out what the scale factor was. So for example, this picture, my green V prime, Z prime, X prime, W prime, that is an image after a dilation of the blue VZXW. Remember, we can always tell which one is the after because it's got the little dashes next to it, the primes. So we did something to this shape to get this shape, and we want to know what. So the nice thing is that to figure out what, all we have to do is we can find the coordinates of any one point and then the coordinates of one other point and figure out what we changed them by. So let's, for example, look at this point W and W prime. I see that W is at 1, I'm sorry, 2, 1. That's a nice point. Over 2, up 1, right? Well, W prime, that's over 1, 2, 3, 4, 5, up about 2.5. So, if I want to know what the scale factor is, I need to know what I multiplied each of these numbers by to get each of these numbers. So we can just divide. So let's say we did 5 divided by 2. Or I can do 2.5 divided by 1. Either one will work. If I do 5 divided by 2, I get 2.5. If I do 2.5 divided by 1, I also get 2.5. That means that this is my scale factor. This is the number that was being multiplied by W to get W prime. So my scale factor that we dilated by is 2.5. And again, all I had to do was find the coordinates of one of the original points, one of the coordinates of the prime points, and figure out what we multiplied by. That's it for dilations. Please let me know if you have any questions. Thanks so much for watching and have a great day.